Okay, this is it, the moment you've all been waiting for me to solve problem 13. I think I got the most questions about this one. First off, I want to apologize because the problem 13, it has 100 apples in the barrel. And that's really hard when you're calculating the combination. I thought we'd all have graphing calculators by now, but I guess I was mistaken. So for those of you who calculated it by hand, power to you. I will be going over exactly problem 13. But the first thing I want to do is I want to set up this problem. I'm not going to solve it, but I just want to set it up. So let's say I have 7 apples in a barrel, and the 7 are rotten. But the barrel has 20 apples in it. If 6 apples are selected, what's the probability that at least 2 are rotten? So I need to take the number of ways I could get at least 2, 3, 4, 5, or 6 rotten apples out of her total number of ways to choose apples. So we're going to have the total number of ways to choose. At least 2 of them are rotten, so it's going to be 2, 3, 4, 5, or 6 rotten apples out of the total number of ways to choose 6 apples. Okay, I don't care if they're rotten or not, just 6 apples. So let's go ahead and start setting this up. So the first thing I need to know is I need to be able to write what's the probability, what's the number of ways that I could get 2 that are rotten. So in this case, I've got 7 rotten apples. Here's a C. And I choose 2 out of those 7 rotten apples. But I have to choose 6 apples total. So if 2 are rotten, then it's going to be the case that 4 are not rotten. Well, how many not rotten apples do I have? 13. 13 not rotten apples. So it's going to be C7 choose 2 times C of 13 choose 4. I need to add that to the probability, to the number of ways 3 are rotten. Okay? That means out of my 7 rotten apples, I choose 3. And out of my 13 unrotten apples, I also choose 3. It's important to note that this part right here, those need to add up to the number we're choosing, which is 6. 2 and 4, 6. 3 and 3 is 6. So let's keep going. So I've got 2 rotten apples and 3 rotten apples. Now I need to have 4. So I'm going to add to this. Sorry, we're going to have to wind it around. I'm going to add to this the number of ways of getting 4 rotten apples, then 5, then 6. Okay, so the number of ways to get 4 rotten apples would be 7 choose 4 times C 13 unrotten choose 2. If I get 5 rotten apples out of my 7, then I only need to pick 1 non-rotten apple. And if I get all rotten apples, then I'm going to pick 0 out of 13. Remember, if you choose 0, it's always going to be 1. Now, I take everything in green, and I have to divide that by the total number of way to choose. I'm going to divide this. This is my division line. We're going to divide that by the total number of ways to choose 6 apples. Well, I've got 20 apples total, and I'm going to choose 6. So this is just how we'd set up this problem. You want to break it down into piece by piece, okay? How many ways could I get 2 rotten apples, 3 rotten apples, 4, 5, or 6, and divide that by the total number of ways I could pick 6 apples out of our barrel of 20. We're going to do the same thing for the actual problem 13, and I'll go ahead and solve that problem. So we have 5 apples in a barrel on which 100 are rotten, and if 4 apples are selected, what's the probability at least 2 are rotten? Okay, so that means I could have 2 rotten apples, I could have 3 rotten apples, or I could have 4 rotten apples. It says at least 2 out of my 4 apples. So remember, it's the number of ways our event occurs over the total number of events. So how many ways, let's figure out our denominator first. How many ways could I choose 4 apples out of 100? Well, that's just going to be 100, choose 4. Next thing I need to do is I need to have the number of ways to get 2 rotten apples plus the number of ways to get 3 rotten apples plus the number of ways to get 4 rotten apples. So let's go ahead and start with 2. So if I've got 5 rotten apples in this case and I choose 2 of them, I've got 2 apples, but I'm supposed to select 4, so I need to have 2 more. How many unrotten apples are there? 95. So I picked 2 out of the 95. 95 are not rotten. And I'm multiplying that. I add that to the number of ways to get 3 rotten apples. So that's going to be 5 choose 3 times 9, combination of 95, and instead of 2 I have 1, right? Because that gives me a total of 4 apples. This needs to add up to 4. This needs to add up to 4. Next, how many ways can I get 4 rotten apples? So that's going to be 5 choose 4 times 95 choose 0, right? I already have 4. Remember, this is going to simplify down to 1. So this gives me, if I take this all and I add this all up, I'm going to get 45,605 over 3,921,225, which simplifies down to 1303 over 122,035, which equals 0.0116. Okay? Now this was really hard to calculate by hand, and I apologize. If that happens again, or in your probability projects, anything's a little too hard to calculate, because I know we don't have graphing calculators. I know some of you have scientific ones. If you don't have a scientific calculator and you'd like one, let me know. But you can just leave it in this form, right? As long as I know you know how to set up the problem, that's what I care about the most, right? Not that you are able to execute every single part correctly and get the correct sum, right? I want to know that you know the thought and the logic behind it. So if you have any more questions on Chapter 6 or Chapter 11 or any of the upcoming chapters, please reach out to me and let me know. I will be driving all day tomorrow. I'll send you some more pictures of my folks' puppy. All right, bye guys.